Probably noticed that on Canvas in the room where you start on that one page. So that if you missed a meeting and want to watch it, or if you decided you want to watch it again or whatever, you'd have that opportunity. So I've been trying to do that when I remember to hit the record button. So solving systems of equations. Remember, there's 4 methods we're going to use overall. And we've already done the first 2. And today we're going to start the third one. So let's just quickly review graphing. Crooked, sorry. Stop. All right, so graphing, quick review here. If I was going to graph the top equation, one thing I would do is put a 1 underneath the -2, because remember, slope's better as a fraction. And then I start the graph at +4 on the y-axis, because that's the y-intercept. And then I go down 2 over 1. And then I like keeping that pattern going, so like down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, because we're only going to make them cross at those points. So if you do that and get all the points on the graph that could possibly be crossing points, then you know the other line is going to cross at one of those, okay? We're never going to make you guess like a half or something like that. And then for the second one, it's already set up perfectly to graph, so I go down 2 on the y-axis because of this. And then I go down 1 over 2, and then down 1 over 2. Bam, I hit the graph. And so that's my solution, is this point right here, which would be what, 4, -4. Okay. This is a great method to use. Solving is a great method to use as long as the equations are written in this graphing form. Okay. So as long as they're written in y = mx + b form, graphing is a great method to use. It's also really good to use if the slopes are fractions. Okay, so like because this equation had a fraction for the slope, it's probably best to use graphing. If you tried to do this with equal values method, you'd have to solve with a fraction, and that's just going to cause a lot of trouble. Okay, so if you have a fraction as the slope, and if you have both equations written in this y = mx + b form, graphing is a great method. Okay, it would probably be my preferred method. Now, equal values method. This one, I need both equations to be written in y = mx + b form again. So that's similar to the graphing method. But notice this time for the slopes, they are integers, right? They're not fractions. So when they're integers like this, this is a great time to use equal values method because it's going to be very easy to solve. Okay. So I'm trying to point out today like when you would use these methods. Okay. Like why do we need so many methods? So this one, remember you set this equal to this. Because they're both equal to y, that means they got to be equal to each other as well. Okay. So it's kind of like this. If I tell you a = 4 and b = 4, what do we know about a and b? Well, they got to be equal, right? Because they're equal to the same thing. That's what we're doing in this method. Is that I have 2 expressions that are equal to the same thing, okay? Which makes them equal to each other. So I'm going to do that. -2x - 1 = 4x - 7. Now you have to solve that. Moving the smallest x is my advice because it keeps the x variable positive. So that cancels. Don't forget to bring down the entire -1. That's one thing that happens, that people lose the negative sign when they bring it down. We'll do that. And then 4x + 2x is 6x, and then -7. And hopefully once you get to this point, you know what to do, right? Add 7. I get 6x is 6. Divide by 6. I get x is 1. Now you're halfway home. On homework, quizzes, and tests, etc. If you get one of them right, that's half the points. It will give you half credit. Okay. But now I need to get the y. So what we do is take that x and plug it into either equation for the x. And this is kind of like what we just did with the fruit and the burgers and the fries, is that once we know the value of one of them, we can plug it in, okay? So I'm plugging in this 1, and I'm going to plug it in for this x right here, because it's pretty easy. So it's 4 times 1, because remember 4x means 4 times that. So 4 times 1 is 4, and then 4 minus 7 is -3. So there's my final answer. And would have worked also if I plugged it into the top one. It'd been -2 times 1 is -2, and then -2 minus 1 is -3 also. So it doesn't matter which one you plug into. I would have probably avoided the top one though, because it's got 2 negative signs in it. The more negative signs are in the problem, I feel like the more chances there are to make a small mistake, okay? And obviously we want to get as many points correct as we can. We're gonna do one more equal values because I want to show you something. So again, these are both written in y equals mx plus b form, and the slopes are integers. So equal values method is a great method to use. So I'd take 2x plus 2 equal to 2x minus 3. Some of you probably already noticed these are the same slopes, right? Which means that it's either going to be parallel or the same line. And since they have different y-intercepts, they're parallel, right? Which means no solution. But I do want to show you like what that looks like when you do an equal values method. So I'm going to move the smallest x. Well, they're both the same. So it doesn't matter which one I move. But what happens when I do that is that these both cancel out. Because 2x and -2x would be 0, right? So I bring down what's left, which is a 2 and a -3. Well, does 2 equal -3 is my question? Nope, right? 2 and -3 are not the same. So they're not equal. And that means there is no solution to this. There's no way I can make those two equations equal to each other. And they're parallel, so we already knew that that was the case, right? That these are not going to cross. If you graph these, you'd have one that's over here, and you'd have one that's down here. And they would never cross, okay? So that's what happens. If you do equal values and you end up with something that's not true, you know it's no solution. Let's say you solve these two equations and at the end you get like 3 equals 3. Well, that for sure is true. And if that happens, then you'd say it has infinite solutions. Okay, so remember, you got to be ready for those 3 outcomes. That it crosses one time and you write down the point, that they're parallel and they never cross, and that's a no solution. And you usually click on that box then, right? Or the 2 lines are identical, same equations, and when you graph them, they look on top of one another, and we say infinite solutions. And then again, you just click the box that says infinite, okay? So that's a review of what we've done so far with solving systems. Today, we're gonna learn substitution. And I kind of already mentioned that this one is not super easy, okay? This one kind of bugs kids a little bit. My suggestion here is if you have a piece of paper with you, that you do this with me, okay? I'm gonna go slow, and that you actually do the steps that I'm doing, okay? I think it's super helpful. Trust me, this is the hard one. And one of the issues is like you're gonna have to use this on the quiz because we can set up the problem so that you have to use substitution. Okay, and I'll show you why that is in a second here. All right, so substitution, here we go. So I want you to look at those equations first. Notice the bottom equation. That's in a good form for us, right? That's y equals mx plus b form. I could graph that equation. It has an integer for the slope, so equal values method could be used on that equation. But notice the top equation is not in the right order, okay? The x and the y are on the same side of the equal sign. This format is actually called standard form. Okay, when they put the a and the b, or the x and the y terms on the same side of the equal sign. That's different than slope-intercept form, where the slope of the y-intercept are on one side and the y is by itself on the other. So notice these two equations are not in the same format, okay? Where for graphing an equal value method, remember the equations always look the same, right? Like if I jump back here, like the y's are on top of one another, the x's are on top, and the numbers are on top. That's not the case here. Okay, so we need a different method to solve this. I wish this thing had a really big eraser. It's got this tiny, tiny eraser. All right, so we need a new method, and we call this method substitution. So here's what we do. Kind of like equal values method, I'm going to circle what y equals. Okay. This is the part where if you could do this with me, it's really helpful. So if you want to write down these two equations right next to each other on your paper, just like they are right here, maybe do that for, I'll give you like 10 seconds. X plus 4y equals 26, and y equals 2x plus 20. Now think back to the little activity we did at the beginning. Like once we figured out that a shake was 10, we could put that 10 everywhere we saw a shake, right? Well, what I know here is that this y equals this blue circle. So any place there's a y, I can put that blue circle. So I'm going to take that blue circle and put it in for this y. So I'm substituting 2x plus 20 in place of the y in that top equation. Now, circling that 2x plus 20 and drawing that loop to the y, I think is a crucial step in this process, okay? I think you get more of these right when you do that. And that's what we're trying to do, right? Get as many points as we can, get a highest grade as possible. So here's what you do after that. I'm going to rewrite this top equation, but instead of y next to the 4, I'm going to write the 2x plus 20. Okay, I'll give you a second to do that. So notice, I just rewrote this equation. Like it's all still here. Here's the x, here's the 4, here's the equals, here's the 26. But instead of writing y, I wrote what y equals. And I got that from over here. Okay, a detail here. Notice I put this in parentheses. Whenever you substitute something in, you should always put it in parentheses. Now, from the last thing we did first trimester, we know what to do when we have a problem like this, right? A number outside of parentheses, we're supposed to distribute. So 4 times 2x would be 8x, and I do 4 times 20 would be 80. So I'm going to do that over here. I'm going to distribute these. The x is going to stay there on the outside because that's not part of this. 4 times 2 is 8x, and 4 times 20 is 80. So you always will have to do this. Once you substitute for the y, you're going to have to distribute. And that's another reason to put those parentheses in, because it's kind of a reminder you're supposed to distribute. But once you get here, the hard part's done. Okay? The hardest part is substituting and then doing the distribution. Now I just add some like terms. So x plus 8x. Remember there's a 1 here if they don't write anything. That's 9x, 1 plus 8. Plus 80 is 26. Then I'm going to subtract 80. Like from this point, I'm hoping everybody's good. So 26 minus 80 is 54. And it's negative. And I divide by 9. And I get x is negative 6. Okay, so I'm halfway home. One thing I want to mention here before I finish this problem, once we substitute in, like up here, once we substituted in that little expression for y, notice there's no y's in the equation now. It's all x's. So now I can solve for x. Okay, you can only solve for a variable, but that's the only variable in the equation. Okay, it's the only way to get it down to one number. So I'm halfway home. Then I'm going to take that x, and if I were you, I'd always plug it in to the equation that's the y equals 1, because that's going to be the easiest one to solve. So I plug in that -6 for x. Remember, that means the -6 is going to go here, and it's multiplying, right? So 2 times -6 is -12, plus 20 is 8. There we go. Okay. Any questions so far on what we've done to this point? You could type it in the chat, or you could unmute and verbally ask me. I'm going to do another example, so maybe I'll just move on to the next example. You can always stop me if you want. All right, let's give it a shot. So we want to circle what y equals, draw a loop where I'm going to put it. I'm going to put it in place of y. So I write my equation, x plus 2 equals 11. And notice I put a parentheses there. And I'm going to put in the -3x plus 18 in that parentheses. So I've replaced this y with that. So you're going to replace and then distribute. Now I do 2 times this and 2 times this. And don't be afraid to use your calculator at this point. When you do 2 times -3, that's -6. So you can just write it as subtract 6x. And then 2 times 18 is 36. Since they're both positive, it'll be plus 36. And now I can just continue solving. So remember, there's a 1 here. So it'll be 1 minus 6, it'll be -5x. Plus 36 equals 11. Subtract 36 from both sides. I have -5x equals -25. Use calculators on stuff like that if you want. It's no big deal. And then divide both sides by -5. I get that x is 5. So I am already halfway home, remember? I have one answer. Now I'm going to take that and plug it in. Probably for that bottom x, right? Because that's going to be an easy solve. So I put a 5 here instead of the x. And it's multiply, so it's -3 times 5. It's -15. Plus 18 is 3. So key steps here. First, figure out what you're substituting where, and then do it, okay? And put it in parentheses. Then distribute. There's always going to be a distribution part of this, okay? So hopefully you remember how to do that from first try. Once you've done that, then it's just solve it for x and then plug that back in. So from there, it's kind of just like equal value method. Once you get that plugged in. All right, let's do another one. Not that one. We're gonna do this one. And then we'll try a couple on our own. So take a look at this one. This one's interesting. In the first 2 examples we did, we had an equation that said y equals something, right? And then we circled this and looped it to the other y. If you look at this one, notice it says x equals this. So this time, instead of substituting into the equation for y, we are going to substitute into the equation for x. Okay, because I know what x equals this time, not what y equals. So one of the equations will either say y equals blah, 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 or one of the equations will say x equals blah, blah, blah. That's the equation that gets substituted, and you circle blah, 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 and that's what goes into the other equation. Okay? So, but after that, it's the same technique. So I'm going to plug that in. So it's going to be 3 times x minus 6y equals negative 24. I left the parentheses because that's where the 2y minus 8 goes. So this equation, 3x minus 6y equals negative 24. Everything's the same except the x. I replace that with what it equals. Then I distribute. So 3 times 2y is 6y. 3 times negative 8 is negative 24. And I have minus 6y equals negative 24. Now, hopefully you remembered adding like terms from first try. But I'm allowed to add the 6y and the negative 6y because they have the same letter. And oh my gosh, those cancel out, don't they? 6y minus 6y would be 0. So I get negative 24 equals negative 24. Does anybody remember? What's the answer when you get something at the end like that? You could type it in the chat if you want. What's the solution to this? Anybody remember? What happens if you get something that's equal at the end? All right. It means infinite solutions. Means these two equations are the same. If you graphed them on a graph, they'd be the same picture. Okay. Remember, if they're equal, that means infinite. If we solve this and we got like negative 24 equals 7, that's not true. That's when we would say no solution. Okay. So you have to know that. Okay. All right. We're going to try a couple of these on together. Okay. Like I said, this is not easy. This is the hardest of the 4 methods. I'd like you to log into the whiteboard. I just dropped the link into the chat. Drop it in a couple times. Click on that and get signed in. I'll give you like a minute, and then I'm going to post a problem. So go.